Hello everyone, a warm welcome to our NoSQL project walkthrough. So here we have used 4 different tools: MongoDB, Atlas, Neo4j, Redis, NoSQL, and LLM as in Groq. So MongoDB will store the NoSQL documents and Neo4j will reveal the relation, and Redis will help us in speeding up the repeated queries, and the LLM we have used as part of the bonus criteria. So it will generate the evidence layer that helps us for insights, and the complete app is organized by a data layer and analytics layer. So I can show you the project structure. So here is the project structure. We have an ETL for data loading and analytics for queries, and bonus for the Redis cache and LLM walk, and we have data in the 3 CSV sample files that is we have taken from the Kaggle. So MongoDB Atlas is our document store. We have loaded 50,000 Stack Overflow questions into a single denormalized collection, and each document, let me show you. Yeah, so each document embeds with the answers array and the tags for that questions. So there are no joins needed. You can see the schema here, like score, creation date, and tags as an array, and as answers as an embedded array. So the total size of the document is like 165 megabytes, and here is the 50 data that we have loaded, and here you can see it is like 165 megabytes because we are using the Atlas free tier, which has a limit of 512 megabytes of data that we can load. So yeah, then I can show you. Then coming to the analytics, so then coming to the analysis, this script runs 8 aggregation pipelines against the collection. So the pipeline 1 tells us the tags array and the counts by tag. You can see the tag she has is on the top with 6,370 questions, and the pipeline 3 tells us about the groups by year. It is showing the question volume picked in 2009. Yeah. Pipeline 6, similarly pipeline 6 have used the bucket operator, $bucket operator, that will show us the score distribution over the 80% of the questions between like 0 to 5. And the pipeline 8, this tells us about the embedded answers array to rank the top answers. You can see the user IDs and total scores, and all the results of this is just saved to mongo results.json. Again, I want to show you that as well. So here we have the pipelines and the answers. It will print for us there. Then we are visualizing the same thing using Mongo charts, which is again free tier. So here in the dashboard, as you can see, there are 4 charts, so all driven by the aggregation queries. So here we have the queries, and let me walk you through the charts one by one. So the top left is the horizontal bar, which confirms that she has dominates with 6,370 questions. The right one tells us about the lines. So the line chart which shows the questions is peaked around sharply in just 2009, and the bottom left is the donut chart, which shows us the 96% of the questions are open and 3.8% were closed. And the bottom right, you can see the top answerers bar chart shows one user is in the 22,000 range, and it accumulated over 11k questions, 11k answers point in this sample alone. Yeah, so in the Neo4j Aura DB, So Neo4j Aura is the graph database that we are using. Again, we are limited to the free tier use. So this is our graph database and the dashboard, so which has 20,000 questions, which is modeled as nodes and relationship. I want to show the most powerful graph here. So this is what the tag occurrence cowork network. You can see all the yellow lines, all the yellow nodes is a technology tag here, appear in the for the same question. You can notice that here the she has is in the center and it connects to .NET, ASP.NET and XML and so on. So this is a star topology which reveals that this is a star topology which reveals that the she has is the gravitational hub of the entire Microsoft ecosystem. And here in the MongoDB you can see it tells that she has was the most popular tag, and in Neo4j it clearly tells us why it is a popular tag, because it tightly couples all the technology community. Then I'd like to show you the cipher queries that we have done. So the query 1, so here we can explore the queries through a shared question. This demonstrates the small world property of the developer network. All the results are stored in, so all results are stored in that Neo4j results.json. Then we have a bonus NoSQL use. So as part of that we have used LLM, Groq LLM. Yeah. Here I'll quickly show, Redis is our third NoSQL database. So a key value store caching layer to MongoDB, and it pulls the tags and the top users from MongoDB. Redis using 4-tier. This is a string with TLL for the JSON full result, and the hash field for the level access, and the sorted set for the real-time leader dashboard. Then the speed comparison we have here, the speed comparison, like as you can see, the simulated MongoDB latency is around 84 milliseconds and Redis get is around 1.7 millisecond, and the speed of factor is around 49x. So basically it is like 49 times faster. Then this is the pattern generally used in the production systems, where same expensive query gets called repeatedly again and again. Then we can show you the LLM implementation. So, few datas. Oh, sorry. So as you can see, we have, as part of the LLM bonus criteria, we have used Groq API. This is the model that we have used, Llama 3.31. Then rather than just generating queries, we have built a closed loop pipeline which will take the questions as in English, and it will generate the cipher queries. A pipeline which will execute against the real database, and then the plain English is so this is the question and the cipher queries, and the results, we will get the actual results, and it will get stored to the result.json that I'd like to show you here. So this is the result.json, like here it is stored. Also noted how many API calls were there and what is the input token and the output token. And finally I would like to show the complete document on that. So this documents covers all the rubric criteria such as meaningful goal and the workflow and the problems that we are dealing and the solutions. Along with that, I can show you how the dashboard of the this is the dashboard of the MongoDB looks like. And and the final dashboard of the Neo4j looks like this. So Here we have also compared like what are the five real problems, the real problems, and we have like compared the results between or the findings between MongoDB and Neo4j. So after using two free tier scale, like in terms of the storage, clearly this is a clear winner because we could able to store only 20K questions in the Neo4j. However, here we have keep 50K documents, and in another thing is in another prospect where the bulk aggregation speed in terms of that for it is like few seconds to for it is like for it took few seconds to for the 8 pipelines using 50K data. However, the Neo4j one is little bit slower, so here is the clear winner. However, if we'll compare the relationship to find the relationship between the question answers and the tags, so Neo4j is the clear winner because it gives us the insights in structure, and the insight we are getting from Neo4j is like very clear, and the query language we have used here is in the cipher and the JSON aggregation pipeline. So here I think, and also one thing I'd like to show here, also a single most interesting thing that we found while doing this project is like according to MongoDB, here it tells that she has is the most popular tag with 6,370 questions. It is useful, but it is bit shallow. But if you'll go to Neo4j graph, here you can see that she has it is just it sits at that center of the star shaped ecosystem like the .NET and ASP.NET generics and etc., and it orbits around with all these like the strong co-occurrence weights. So this structure gives us the insight that it is not only a popular tag, it is the gravitational center of the all Microsoft community. So this is the difference between a document database and a graph database on the same data. And I thank everyone for watching. Thank you.